Hello, my name is Madix Johnson.
And I'm Kara Harris, and today we're going to be demonstrating blood flow through the human body, and we're going to compare it through a healthy blood vessel and a diseased blood vessel with atherosclerosis. So we 3D printed 3 different vessels. We have a healthy one, a middle stage atherosclerosis, and then we've got our most occluded, most diseased one already set up on the tube here because it took the longest to set up, so we just did that first. And here we have water that's dyed red just to mimic the visual aspect of the flow, and it's easier to see throughout the experiment. And we're going to be using a peristaltic pump, which we are able to set a predetermined flow rate in milliliters per minute, and that's just going to mimic the pressure-driven flow in the human body. And that's just going to push it through, and it's just going to disperse in the end. And Madix is going to show you the math.
Hi friends, let's do some math, shall we? So, starting up top here, we want to find our change in pressure because obviously an occluded blood vessel is going to have a different blood pressure going through it than a healthy vessel will. So, in order to find delta P, we will take gamma over R, and in this case, gamma is the surface tension coefficient. In our experiment, we will be using water. And then R is the radius of the inner diameter, or inner tubing radius, and that'll find delta P. Next, volumetric flow rate, which is already set on the pump to 450 milliliters per minute, and this is equal to this, delta P pi r to the fourth over 8 mu L. In this case, mu is the viscosity, and like I said previously, is water in this scenario. Q is also equal to average velocity times area, which is good for us because we already know the area because we have the radius. Easy to find. And then if we wanted to find the average velocity, we could just take look at that, Q over A is equal to average velocity. And then finally, we could find the max velocity through our flow using 2 times average velocity. Awesome. Now, let's get into the experimental setup. Kara, my wonderful lab assistant, will be demonstrating this simulation for us. So first, like I said, we have our volumetric flow rate set to 450 milliliters per minute. And now, Kara will begin putting fluid throughout the tubing. And then it'll end up coming through this blood vessel, as you can see, is occluded. And as you can see, the occlusion causes the blood to kind of spurt out, in a sense. And as you can see, our flow is not fully developed yet. It's not steady state flow, although it is getting there and is getting more parabolic in nature.